Hello guys and welcome back. So let's try to deal with the performance issue. Now you probably haven't seen it if you don't really see the frame rate. So let's take a look at that. If you go to here and check on show FPS, you can see we're somewhere close to 120. If we run it, you can see how our frame rate is then dropped to 90 something to 100. Barely reaches to 110, so we're basically losing I guess 10 frames per second in that case. Okay, we can also verify that by going to the in-game UI, and then we can find the headshot, okay, and just simply delete it. Right, that means that it's no longer there, and if we play it right now, you can see how it's 120 again. Right, so it's very clear that the performance hit we're taking is because of the render target, and you can see now how without it we're back to somewhere close to 110 and 120 instead of 90 to 100, something like that. Now that's not because we are creating a new world, because if you just drag one of these guys, right, our render actor, and play it, you can see how we are having the same issue, right? Somewhere from 90 to 100 instead of 110 to 120. We can also F8 to jump out and just simply delete this character. You can see how the frame rate will jump back to 120 again, right? Somewhere close to 120, right? So it is not because we are rendering a new world. It is not because of the previous scene either. It is because of the render actor that's rendering with the same frame rate as the game. Okay, so a few things you could do, right, is to reduce the performance hit. One is to reduce the render target's format. It's 256 by 256. If you know that the headshot is going to be smaller than that, you can lower down the resolution. Resolution is going to be a big thing here, right? If you lower down that, you'll be able to get better performance. Another thing is that because we're rendering it as just a headshot, it has nothing to do with the gameplay, right? So one thing we could do is to not tick it as fast as possible, right? Let's comment that out. A better way of doing this is just to not render it that regularly, and to do that we can actually use a timer instead to render it. Okay, so we could do it actually just right here in the begin play part. Yeah. So we can actually say get world, get timer manager, set timer, and the timer will be you needing a timer handle. I'm gonna call this guy render timer handle, something like that. And that'll be the first argument. Second argument is this. Third is ampersand u headshot renderer colon. Let me call this function update capture. Okay, and then the looping will be true because we actually need to loop it. Oh, actually, before that, we need to also type in have the our frame rate. So let's say that we have a variable called frame rate. Then the time duration for the repetition, right? How long does it wait to repeat the render again? Will be 1 divided by the frame rate. Render frame rate. Okay, so we just need to create those two members. Render frame rate will be an integer. Which reminds me, if we want to do float calculations, that's gonna have to be 1.0, something that's a float number. Okay, and then again the frame rate will be an integer. Uint 8. I guess that would be enough. We're not going to be able to reach anything further than 256. Okay, frame rate. How did I call it? Render frame rate. And we can initialize it with a value of 24. That's the standard for animation rendering. and then one more argument, one more member that's going to be the function we call, right? And that's going to be a U function. Doesn't have to be a U function because it is just a timer, so we don't need to have a U function, just a regular function. And that's going to be void update capture. And here's what we call this. Okay, now it becomes timer based, and we only updated 24 frames per second, and that's what the timer does. Now, just to play safe, right, we also wanted to be able to get rid of the timer if we're destroyed. So if get world get timer manager, clear timer, all timers for the object, so that we're sure that this thing is no longer ticking. Okay, that's basically it. All right. Okay, I think that should be it. Let me go back here to the level, to the editor, and compile it. And this should reduce the amount of calculation considerably, because we're only rendering 24 frames per second instead of 110 or something. So that's a big difference. Let's play this again. Oh, let me get rid of that one. And oh, we're not seeing the headshot. I think I deleted it. So let me add it in one more time. That would be headshots, and then I have the sets to content. Let me just anchor it to the lower left and just drag it over here. All right, now you can see we're still taking a little bit. You can see occasionally we're reaching 120, right? So this is actually way more faster. It's almost like taking a very limited amount of performance. Okay, so we're almost the same as before now. We're just rendering it way lesser. And you can also see that the animation is still very fluent. Okay, if you want it to be a bit more fluent, you can go for the movie level resolution, which is 30 frames per second, if I'm not mistaken on that, which means that I have to be able to access that through the headshot. Yeah, that's right. So through here, we can improve the quality just a bit by going to the graph and then make it 30. And that's still way better than rendering it like 120 or something. You can see how it is almost like very fluent. You can still see where occasionally reaches 120. That's actually very optimal. Okay, all right. So that's going to be the performance consideration there. Some things you could do is to avoid using the raw style pointer with a shared pointer or unique pointer, whatever that works for you. But always be aware that it's previous scene, however, it is not a U object. So I'm still wondering, based on the documentation, this may not even work with the shared pointer. You have to see it yourself. But this is garbage collection object, so maybe it's doing something, right? It's doing something internally to manage the resources, and I'm also managing it myself manually because this is not something that's necessarily wrong, right? The functionality is there. This is the way people code stuff, right? And this is also somewhere you see how inside of the engine that they're doing it with the new keyword somewhere here and there. So don't be afraid of doing it, but again, be my guest if you want to try to use some some memory management facilities like the shared pointer. Okay, all right. So one thing we could do to make it even better is to make sure that we are actually not only rendering this skeletal mesh, right? So we can actually swap this out whenever we need, if the player is using a different character, right? Those kind of things. All you have to do is specify an interface to deal with that. Okay, and hash out renderer is here. I at the moment we're not able to do it because we have no way to call it through C++. But we could create an interface here that we can set to the actor renderer, and then we can maybe have a public function to do that, I think. So we don't have any public field here. Set render asset. Okay. Don't have to be constant because I think we're changing things. We have the renderer, right? So we need to do something to render the asset. Of them will be a skeletal mesh. And then another one is U and animation interface. Call this guy blueprint, something like that. And then we need to tell the actor renderer, right? And we don't have access to these either because those are also private. Oh, actually, we don't have access to it at all. Okay, let me then make it something public here. U function blueprint implementable event. Implementable event category equals to renderer, and then we have that function there. Yeah, have the same signature just to be able to do that. Okay. Meta equals to display name equals to set render asset. So basically we can pass it over to Blueprint to deal with it because that's the visual thing I'd like to be handled in the editor. Okay. Alright, hashshot renderer. And this is something Blueprint callable. No, I need to make that to be called by Blueprint as well. U function blueprint callable. Category equals to hashshot. Okay, that should be it. Go back here and compile. Oh, let me close that. This one. So that way we can call this function through Blueprint and set up the things we need to set up. Okay, now in the in-game UI we can specify that interface. Okay, first of all, our hashshot is variable. That's nice. Okay, so we create a custom event, set render asset, and drag that over here, and we can call that okay. So that we can drag the mesh over there, drag the blueprint over there, right? And whoever that needs to be different, we can call this function basically. And I believe we can do that in the player character, which I'm using the Paragon Crunch. Okay, so after adding to the viewport, we can also say, hey, set render asset. Okay, and we can use our own mesh, right? Get mesh, get skeletal mesh, will be the mesh, right? And then the blueprints. Oh, well, this one may not be true. Get animation blueprint. Or this one. Get animation instance. That'll be the one being used. Oh, that, yeah, we could be able to pass that over. Whatever animation we're using is the same animation being used by that render asset. And of course, that doesn't really do anything at the moment because this is the key 2 version that we're calling. And so eventually that reroutes to the renderer. Whoops, back here. Renderer, which is here. Okay. So we just need to override that function. Set render asset. Okay, so you can get the skeletal mesh and set skeletal mesh. Okay, and then set animation instance class. Get class, and that goes to there, I believe. That could work. Yeah, so now we're basically now rerouting the player characters mesh to be the mesh being used. Okay, let's see. So now we should be able to see the same result. We're loading the same character, right? And if we were to change the character to be something different, do we have some? Yeah, we have some other ones, like the military version. Right, so we have a different one here. It's compiling shaders. Just to show you, right, we were able to reroute it to a different character now. Let's give it some time to prepare the shaders. That's one thing I am always wondering, like if they are able to somehow make this process lesser painful, because it's always time consuming to see the compilation to be finished before you can do anything else. That's really like a some painful process to go through. All right. Oops, that's how I changed it. Oh, I'm changing that one. Oh, that also does the job. You can see how it's changing back to the characters, right? Which means that it doesn't really matter what's in here, right? It really matters what's in the player characters. So even this one is kind of like nothing. Even put in like a mannequin there, doesn't matter, right? Because the player character will be the one eventually being used. So that's going to be making it more flexible. Whatever the player character is going to be the hash out character as well, with the same animation blueprint in there, which could be interesting there too, because you can actually have some fun with what kind of animation you want to play in the instance. You could also create a special blueprint that does something else, right? That can be your choice too. So there's a lot of possibilities to have some fun with, but that should be, first of all, the performance consideration that we can do to get it to perform better, and secondly, how to hook it up to be actually reading the correct mesh for the correct player. All right, that's it for the entire Hashout renderer tutorial series. Hopefully things here works for you, and let me know if you have a different idea or different recommendations on how we should be able to achieving this. If I can add something more on this, I think if you elect to, right, you can be for sure, and I have tested already, is to actually not using the render target, but rather you just not not use the preview scene, you just go look at how it's setting up the world there, the U world, right? You set it up yourself, right, in your native code. And then you can see there's a bunch of things. Maybe you can avoid doing those lights and stuff because you don't need them, right? You can go for a simpler setup than the preview scene, but you can make your own U world. Just remember that in the destructor of the preview scene, you can see how it's freeing up the memory of the world. So be sure to do that as well, and then you should be fine with just having a bare bone U world, and it will be fine as well. So something worth trying. And yeah, that should be it for this video. Thanks for watching.